So our first learning goal today, come over here with me. Our first learning goal, it's kind of low, I'm sorry. I can define the functional relationship between input and output. So that's kind of what we're going to be working with first in our notes today. We have a couple of pages that will cover that learning goal. You should be capable of talking about relationships and functions. So the first thing we're going to do is it says find the relationship between the two parts of each statement. So in a function, one thing relies on the other happening. So if there is a relationship, we can say, you know what, I should be able to say what depends on the other, okay? So like in the model there it says, Lisa gets paid $10 per hour for babysitting. It's already set in stone how much money she's going to make per hour, right? How much is she going to get? The $10 per hour. So that's already set in stone. But there are two things that can change in this particular situation. One of them being how much is Lisa going to make total? What's her total amount she will make? And the other thing is the number of hours that Lisa actually babysits. So those are changeable. Babysitting hours, how much money she makes total. The $10 per hour, that's not changeable. So when we're talking about a relationship, we're talking about the things that can change. And that one of them changes based on the other, okay? So in her situation, the amount that Lisa makes total depends on how many hours she babysits, right? That makes sense. If she babysits 5 hours, how much money is she going to make? $50. She gets $10 an hour. So she would make a total of $50 based on the fact that she babysat for 5 hours, okay? So what we're going to do here first is we're going to decide what's going on, what's the relationship between, and then which one of them is dependent upon the other, okay? So in the first one, gas costs $4 per gallon. Notice that the two changeables are already written there for us. The total cost that you'll pay for gas, and the other is the number of gallons of gasoline. So which one would depend on the other? Would the total cost of the gas depend on the number of gallons of gas, or would the number of gallons of gas depend on the total cost of the gas? Which one do you think, which one would depend on the other? How much gas you use, would that depend on the total cost? Or would the total cost depend on how much gasoline you purchase?
How much gas you get?
How much gasoline you get?
Gallons you get depends on the cost.
The number of gallons you get depends on the total cost? Well, yeah, if you go with only a $20 bill, that's probably very true, right? What if you're just going to fill your car up with gas? What happens when you go fill your car with gas? What do? None of you have a car yet? You don't have to pay for gasoline yet? Okay. Oh, you do? Okay, well then, what do you do when you go for gas? You go and pump it in. Yeah.
The price on the top of the gallons.
Oh, and the price keeps rolling as you keep putting in more gallons, right? Yeah. And which one moves faster? The price. Yeah, the price always moves faster than the number of gallons. That's a crazy thing. So, what's happening there? What's depending on what? When you're pumping it in, you're putting in how much gasoline, and either it stops because it's full, or you stop it because you're like, oh, look at how much money this is. So wouldn't the total cost of gas, wouldn't that amount that you see there, that total cost you're going to pay, wouldn't that depend on the number of gallons you pump in? Not the other way around? You guys are scaring me. I'm not sure if you're going to be able to handle this. So notice we have nothing in there about the $4 for every gallon. We don't, that's not important in the relationship. What we can change is, what's changeable is how many gallons of gas are you gonna put in? And then, based on how many gallons of gasoline you put in, that's gonna give you that total cost. That's gonna change according to how much gasoline you actually put in. Number 2, Tina makes $8 per hour for her waitress job. Well, again, the $8 is set, that doesn't matter. What can change in this problem? Well, they say how much Tina makes can change. And that would be a total, not per hour, total, how much money she makes altogether, and how many hours Tina works. That can change. Okay, let's decide then which one depends on the other. Now, like, what can be in control? Because the control gets to be saying, you're going to have to depend on me. So what do you think is in control here? And what's the dependent one? The amount of money she makes is what? Dependent or in control? The dependent, isn't it? And what's in control? How many hours she works is in control. So that, write a statement describing the function. What depends on what? We just said what's in control is how many hours Tina works. So we got to fill in the end of the sentence. And how much Tina makes. That depends on the number of hours she works. So if she waitresses for 2 hours, she makes $16. She waitresses for 4 hours, she makes $32. How much she makes altogether is dependent upon how many hours she's actually waitressing. Okay, questions? Because in the next two, we have to decide what are the things that can change. So let's look at number 3. What are the 2 changeables in number 3? That strawberries cost $5 per pound. What are the 2 things we can put in the boxes that show the relationship? Sam? The cost of strawberries, okay, so can we call that total cost? I don't like how they didn't there. The total cost of strawberries? You know what, I'm going to have to start outside the box because that's a lot to write. Total cost. Strawberries is a big word. Of strawberries. Okay, that's one of the things in our relationship. Wait. Dollars per pound. Well, wait a minute. We already know how much they are per pound. How much are they per pound? They're expensive strawberries. Yeah, they're $5 per pound. Ugh. You think that's a changeable thing? No, probably not. What is changeable in? Yeah, the number of pounds bought. That you can decide. But you can't go up to the checkout with your strawberries and say, I only want to pay $1 a pound. But you can decide how many strawberries you're going to buy, right? They've already said they're going to pay $5 per pound. Okay, now we got to figure out which one is dependent on the other. $5 is not involved at all right now in describing these relationships, like what are the things in the relationship and what's dependent upon what. We don't care about the $5 at the moment. We just care about which of the 2 is dependent upon the other, or which one's in control. Jenny? The number of pounds depends on the total cost. Okay, so basically, is this how it works? Do we go to the grocery store, people? Listen to me carefully here, because you're having a hard time deciding how this relationship works. Do we go to the grocery store and go to the checkout and hand them $10 and say, I want to buy some strawberries? No, what do we do?
Go to Aldi, grab some, and then
You go pick out your strawberries, and then you come to the checkout and you pay for them, right? They ring them up and you pay for them. So is the number of strawberries you buy dependent upon how much money you have? I mean, it kind of is. You can't buy unless you have enough, but what's in control though? What takes charge in this situation? What did you say you do? You come in the store and you do what? You go pick out strawberries. And then when you take them up to the till and you're going to pay for them, they tell you how much you owe them. So the total cost is dependent upon how many strawberries you actually buy, isn't it? You pick out. So the total cost it is a tricky thing to try and figure out what's dependent upon, because we like to think of it as, well, I only have so much money. The total cost of strawberries depends on the number of pounds bought. You just kind of think of it like in everyday life. What happens? Well, you don't go to the store and hand them money and say, how many strawberries can I get for this? You give them how many strawberries you want, and they tell you how much money they want. What do you think the two unknowns are in number 4? What has a relationship in this problem? There's a $1 processing fee for each ticket purchased. What can change? What's one of the unknowns? Come on, we got lots to do here. We're going to be working past the bell. What's one of the things that can change in this? Pardon? Yeah, how many tickets you're going to buy. So number of tickets purchased. Okay, let's start with that one. Number of tickets, and we'll use the word bought just because it's shorter than purchased. So you get to, that's changeable. You can buy one, you can buy 100, whatever. What else is changeable? What's the only other thing they're talking about in this problem? They're talking about tickets. We already described that. What else are they talking about? The processing fee, aren't they? We don't even know how much the tickets cost, do we? We just know that for every ticket you purchase, they're going to charge you $1 processing fee. So the other unknown is the total processing fee. Okay, now we have to decide which one's in control and which one's dependent upon that. How do you typically, like, if you're, do you buy tickets, or your parents buy tickets, or somebody buys tickets? Do they say, oh, I got $100, so I'm going to buy however many tickets I can with $100? Or do they typically say, well, there's 6 of us, and we all want to go, so we're going to buy 6 tickets? Is that typically how it goes? Yeah. So that seems like it's kind of in control, isn't it? And what's the result of that? If we did buy 6 tickets, how much would the processing fee be? This is not a trick question. $6, $1 a ticket, right? So what's dependent upon what? The number of tickets bought depends on the total processing fee. So again, listen carefully. Total number of tickets bought depends on the processing fee. So because you have $100, you're willing to buy 100 tickets. Or is it that because you only need 6 tickets, you're going to have to pay $6 for a processing fee? Isn't the processing fee dependent on how many tickets you buy? Yeah, this is hard to understand, isn't it? Okay, the total processing fee, that's what's dependent on. It depends on number of tickets bought. So typically, we decide how many tickets we need. That's what you gotta think of. What do we get to be in control of? We get to be in control of, or what do we want to do? We want to buy tickets. Well then, if we buy tickets, there's going to be a total processing fee that depends on how many tickets we bought. So even if you have to think of a situation like, okay, well, what if we have bought a ticket for everybody in our family? How much would it cost us? And then kind of think of it that way. Okay? Okay, well, we're going to move on, and hopefully that will click at some point. Because now we're going to work with input-output tables and a function machine. So that one that's in control, like the number of tickets you purchase, that's what we call the input, and the output would be the total processing fee. The output is what is dependent upon what happens, the one that's in control. So we don't know what this is representing, we just have a table, and we're supposed to find the rule for, how do they state it? Look at the function and tables of input and output, complete the statement that describes each of the functions. So we're going to go over here to the side, and we're going to say, what do we do to 3? What do we do to 10? What do we do to 0? What do we do to 20? What do we do to 100? What do we do to each of those inputs to get the output that's right beside it? Tyler, did you know it? Add 5. If we add 5 to 3, sure enough we get 8. If we add 5 to 10, sure enough we get the 15 in the output column. If we add 5 to 0, that's 5. If we add 5 to 20, oh, yep, that's 25. And by the way, it has to work for the whole table, okay? 100 plus 5, yep, that's 105. So notice the rule that they wrote right here. Circle that. The input plus 5 equals the output. So in other words, if I said to you, if the input was 70, what would the output be? Wait. You want to do what? The next question already? Can we finish this one first? If the input is for this one, what if I said the input is 70? Tell me what the output would be. If the input is 70, what would the output be? 75, you just add 5. If the input was negative 10, what would the output be? Negative 5, because you would add 10 to negative 10, 5 to negative 10, and you'd get negative 5. Okay, Wade is all excited to tell us what's going on in number 1. What's going on, Wade? He thinks we're multiplying by 3. Well, before we take his word for it, we're going to check it out. Everybody's going to do this. He says take 5 times 3 and you should get the output. Input 5 times 3 gives you output 15. 6 times 3, what is that, class?
18.
It is 18, and that's what the output is. 0, the input 0 times 3. What's 0 times 3? 0. Input 2, and he says times 3, is that, what is 2 times 3? 6. Well, it matches the output. 3, the input, times 3 equals, 3 times 3 is 9, and that's the output. If all of this matches, we've got the rule. The rule is the input multiplied by 3 equals the output. Okay, and that's how we're going to show our work for these, okay? So, you go ahead and first thing I want you to do is write down all of the inputs. And then you decide what are you going to have to do you think, to them. So when we stick 12 into this function machine, before we stick it in, we gotta say, what are we gonna do to it so that we get the output of 5? We have to subtract 7, you think. Let's try it. 12 subtract 7, that's 5. 17 subtract 7, what's that? 10. 9 subtract 7, what's that? 2. 7 subtract 7, what's that?
0.
And 107 subtract 7, what's that? 100. Do all of our outputs match what we have in the table?
Yeah.
They do, don't they? So we are going to be able to say that the input, what? Minus 7 equals the output. Okay, you try number 3 totally on your own. See what happens. Don't forget to support your answers over alongside the table. So you shouldn't even be looking at the table while you're doing your work. You should just say, write down your inputs and then decide what you're going to do to each of them. And then go back and say, do my outputs here match my outputs there? What's the rule for this one? Divide by, so the input, what?
Is it
The input, we're going to say it nicely. Let's say it, like intelligently. The input divided by 5. I like that. Equals the output. Okay, we have an understanding of that. Is that better than the first thing we did?
Yes.
Okay. Input-output relationships. Input is in control. Output is the result. It is dependent upon. The output is dependent upon the input. So, what was the input in the situation? Okay, say, no, don't be on this last page starting in already. Go back to the first page. Go back to the first page. The front side of the one we were just on. What would the input be in number 1? What would the inputs be? The total cost of the gas or the number of gallons of gas? The total cost depends on, you will figure out how much total cost it is depending upon how many gallons you buy. I like this one because input, you put the gas nozzle into your car and you see how many gallons you get. This is the input. Let's everybody write this. We need to start understanding this. The input is how many gallons of gas you put in.
Any students headed to the resource center, please use the counseling door at the top of the stairs. Thank you.
The output is what's dependent upon that. So the output is the total cost of gas. How much you're going to pay total is dependent upon how many gallons you put in to the car. What's the input in number 2? How much Tina makes depends on, is the result of how many hours Tina works. What's the input? How many hours Tina works. This is the input. And how much she's going to make total is the output. We would take how many hours she works, take it times the $8, and we would have how many dollars she would make altogether. Okay, let's do one more. What is the input in number 4? And what's the output? Total processing fee, number of tickets bought.
Total process fee.
Okay, it does depend on it. That's right, we wrote that. So what's the input and what's the output? Is the number of tickets, okay, let's go above the boxes here. Is the number of tickets the input or the output? And is the total processing fee the input or the output? The total processing fee depends on, it is the result of, would you do this? The result of, the total processing fee is the result of how many tickets you buy. The result should come after the equal sign. What comes after the equal sign, the input or the output? The output. So the total processing fee is the output. It comes out of the fact that you're going to put in how many tickets you actually bought. We'll get this. Okay, let's go to our last page now. We're talking about the coordinate plane, making sure we have a good understanding of that, okay? So first of all, I just want us to jump down to the coordinate plane down here. The reason it's called the coordinate plane is because every point that you put on it has 2 coordinates. What are those 2 coordinates called? X and Y. Okay, well then, what are these guys called that are crisscrossing in the graph? What are they called? What's the horizontal one with a little X at the end called? X-axis. What's the vertical one with that little Y at the top called? That's called the Y-axis. Okay, so we gotta make sure we understand those parts of it. And then now we'll go on to doing some of the other stuff it says to do up above. Okay, so we have, first of all, we're supposed to label the quadrants. What are these? What does this say? 1, Roman numeral 1, Roman numeral 2, 3, and 4. How many quadrants are there on a coordinate plane? There are 4, aren't there? Anybody know where we start with number 1? Where did they? Which one is called quadrant 1? Upper left, upper right, lower left, lower right. Which one? Right here? Upper right, yeah. They start here. There's quadrant 1. Put that right on your graph there. Now, where's quadrant 2? We have the upper left, we have the lower left, we have the lower right. I'm going to give you a little hint. It goes counterclockwise from quadrant 1. What's counterclockwise? This way or that way? Counterclockwise is this way, going backwards on the clock, right? So where would quadrant 2 be? Upper left. Quadrant 3, we just keep going around the clock here. Quadrant 3, quadrant 4. And notice we use Roman numerals, not numbers, right? The Arabic numbers. Okay, that's the quadrants. We've done that. Now let's go up here and see what the next thing we're supposed to do. Each point on the graph has what's that called, that name we call the points on the graph? Anybody know? It's a 2-part name. Anybody know what they're called? Because order matters in them. And because there's two coordinates in them, they're called ordered pairs. So each point on the graph has an ordered pair name. And the ordered pair name starts with which value? The x value or the y? X. X comes first. It gets to be first in the ordered pair, followed by y. And notice, parentheses around two numbers separated by a comma means you have an ordered pair, means you have a point on a graph. Okay, locate and label the origin. Where's the origin at on a coordinate plane? In the middle. In other words, what's the middle? What if my coordinate plane had the y-axis over here and the x-axis up there? Would that be the middle right here? Would this be the middle if they were crossing here? No, that wouldn't be the middle. So instead of saying the middle, we're going to say where what? Where the axes meet, where they cross each other. So we're going to say this, so let's just write it like this. We have this is our origin. What is its ordered pair name? 0, 0. The x value is 0. The y value is 0. 0, 0 is our origin. Okay, now we're going to graph these other points just to make sure that we understand graphing. Ordered pair 3, 4 is point A. How do we get to ordered pair 3, 4 on the graph? What do we do? Okay, we always start at the origin when we're plotting points. So we go how many units to which direction from the origin? We go 3 units to the right. And then what do we do to graph to get to 4? We go up 4 and we put ourselves a point right there and we call it A. Over 3, up 4. You guys can probably see the lines on yours better than I can see mine, right? It should be at an intersection of some vertical and horizontal lines, shouldn't it? Okay. How about point B? How would we get to that one? Back to the origin again. What do we do? What does that -7 mean? What does -7 mean in that ordered pair? Go to the origin and do what? Go left 7, and what does the 2 mean? Go up 2. So we're going to go 7 over to the left, follow along, and we're going to go up to 2 up on the graph, and we're going to label that one B. How about C? Ordered pair -5, -4. What do we do in that one? Left 5 and down 4. 5 to the left and down 4. I can't see my lines at all, so you guys make sure you're putting them in good locations. And how about D? What's its ordered pair name? 8, -2. So we go 8 to the right and down 2, and we have our point D. So we have 1 point in each quadrant, don't we? Yep. Okay. Notice what it says. The last thing we're supposed to do is identify the signs of each coordinate in each quadrant. So in other words, any point that is in quadrant 1, no matter where it's at, point A is there right now, right? Any other point we would plot in quadrant 1, what could we count on for their signs? The x value would always be, well, it's always first, but what sign would it be? Positive or negative? Positive, because we have to head to the right, don't we, to get there. And what would the y coordinate be? Positive, because we got to go up to get into that quadrant. So we would have the signs for all points in quadrant 1 should be a positive x value, a positive y value. Is that true for our point A?
Yes.
Okay, we have a positive x value, we have a positive y value. Okay, how about for quadrant 2? What would the signs be of the coordinates? X would be what? Negative, because we got to head to the left. And the y would be positive because we gotta head up. Was that true for point B? Did it have a positive, a negative x value and a positive y value? Okay. How about for quadrant 3? What's the x value? Negative, because we gotta head left. And what's the y value? Negative, because we gotta head down. So we have a negative x, we have a negative y. How about quadrant 4? We have to head right. That makes for a positive x. We have to head down. That makes for a negative y. Notice, do any of them have the same exact thing going on? This one has two positives. That one has a positive negative. That one's at two negatives, and that one's a positive negative. They all have their own characteristics, don't they, each quadrant? Okay. Now, points that are on one of the axes, whether it's the x-axis or the y-axis, are not considered to be in a quadrant, okay? We talk about them being either on the x-axis or on the y-axis, and we don't talk about them being on a quadrant. Okay, so don't be confused by, well, what about, the fact that, how do I know if my x is positive or it's negative if it's up there on the y-axis? We don't talk about points being in a quadrant when they're on an axis. Okay, let's get out some